Okay.
నీరు కనపడుతుంది.
నేను మ్యూట్కి వచ్చేసినాను. నేను అన్నట్టు ఉన్నాను సార్, కరెక్టే వచ్చింది. నన్ను హోస్ట్ చేసిన సేమ్ సరిపోతుంది, నేను చూస్తాను. ఫస్ట్ ఉమామేశ్వర మేడం ఇది వచ్చింది. ఓకే ఓకే వచ్చింది అంటే లెట్స్ స్టార్ట్.
Good morning to one and all. It's my great privilege to welcome you all for this one-week International Faculty Development Program on Research Challenges in Mechanical Engineering conducted by Mechanical Engineering Department of Sri Venkateswara College of Engineering and Technology, Chittoor. I welcome each and everyone for the third day of the session. It's my great pleasure to introduce our today's guest, Dr. Eriki Anandagaru, Associate Professor in Federal Technical and Vocational Education and Training Institute, Ethiopia. He has completed his doctorate in automotive design and manufacturing from University of Newcastle, Malaysia Center, and Masters from Satyabama University, Chennai, and Bachelor's from JNTU, Hyderabad. He has published more than 30 journals and papers. Now I invite our today's guest, Dr. Eriki Anandakumar Garu, to give his lecture on the topic of precision grinding of Ti6Al4v using Novel Bondless Diamond grinding wheel. We welcome you, sir.
Yes, doctor. Yeah, yes. It's okay. Yeah. Yeah. So we cannot hear you, doctor. Can you hear us? No, I cannot hear you. You no, it's not audible. You please, you can increase your volume or your PC or a mobile, whatever. So you again what you do is again you do this pin, adjust your pin so that. Professor, you are unmute. You are on mute now. Unmute yourself. Professor, we could not hear you. You are in mute condition now. Please unmute yourself.
Hear me?
Yeah. Now we can hear you.
Yeah. Okay. Right.
That's good. That's good.
Yeah. Now I think can you hear me? Right.
Right.
Yeah. Okay. Thank you for giving opportunity, Dr. Hanna. So yeah. Good morning, all. Right. Today I introduce myself. So so I think I have to started my technical background from IIT. It's a ITI welder and diploma in mechanical engineering and bachelor of mechanical engineering of computer aided design specialization in mechanical engineering and PhD in automotive and PhD in mechanical engineering. So I have double PhD. So right now I'm working as associate professor in FTVT University in Addis Ababa, Ethiopia. So okay. So my research all in precision of titanium alloys. So I'm going to manufacturing using how you can make it that material fine polishing and fine finishing and finding the fine parameter for using turning operation, milling operation, and grinding operation. These three scenarios I am going to do all this kind of things. Now, I want to share with titanium grade 2 material and grade 5 material how you are going to do the machining. Now I'm going to introduce one type of tool, that tool called bondless diamond grinding wheel. It's not available. You have to be ordered from Malaysia. So I was working as a Malaysia past 10 years. So there I have to work on this in this bondless diamond wheel. So I can show you how the tool will be manufacturing and how it should be used for the manufacturing in the way. So these are all things I'm going to introduce. This is one small type of tool like or you know, you see our grinding is like big wheels or something like, but this is the novel diamond wheel. So it's the abrasive particles are different scenarios. So in this case, how you are going to use that one, make, mold and bond, and it's very expensive tool also because the materials are very expensive. So how you can make it to balance the both of machining and manufacturing in this case. Okay, now you can see. Right. Now you can see the titanium compounds are not a great degree of hottest machining of axial. That means its expense point will be forming of the novel bondless jewel crushing wheel. It's just like one type of crushing wheel. How it could be, we'll see the one how it is. So while machining of titanium composites, the cutting zone temperature is so high because it's very hot material. So that's what is the lessening of temperature of cutting zone, great change in chip granulated force cooperation and the utilization of novel bondless precision stone crushing. So in this case, you see that bonding tool, how the tool will be planned. It's a plan of surface quality because of thick, concentric, appropriate precision stone wheel, the coarseness. The novel system for asperic era can give preparatory results in this case. We'll see how the results will become here. The main objectives on this scenario, the principal objective is steady to exhaustion of diamond wheel in granulated operation 6Al4v. Very good. Some bomb examination, the basic property of cut and molecular measurements. So I will show you how you are going to do these molecular measurements and everything. And titanium, the second objective in this webinar, titanium alloys are extremely difficult to machining and economically is very expensive. Of course, mostly that is in aerospace. The combustion chamber is very nowadays combustion chamber after 6 months or within 3 months or 6 months. So automatically the combustion chamber, the inside, the fine finishing gone because of the burning of fuel. So what it could be, we are going to like how automobile reboring all kind of things. Similarly, every 6 months or 1 year, the combustion chamber going to be spoiled. So that means not spoiled. It's the combustion chamber surface finish going to be gone. So we have to use this kind of technology, this kind of novel bondless grinding wheel. We can make to again machine that combustion chamber, and we can make it again to use. So in this case, I'm going to introduce here novel bondless diamond grind. Because of this one, to minimize and machining cost using this wheel. The performance of nanometric finishing grinding, that's a very, very, very fine nanometric finishing of grinding. That is the only scenario we are going to be focused on. First of all, you see here properties. So you should know the properties of the material. The ultimate bearing strength, compressive yield strength, ultimate shear strength, and smoothness and notch. So these are all, if you know the parameters in between, so we are easy to machine that combustion chamber. So that if it is compressive yield strength, how ultimate strength, how the parameters, if you know, you can operate anyone. In this case, if you open anyone, operate the one, of course, automatically you can get it. And you see what problem here we are going to be finding. So in which the problem, how the problem statement it could be to explore the execution of bondless crushing wheel in granulator. That means we know how the grinding, normal manufacturing grinding wheel, we are using type of abrasive particles. All right. So here, what kind of abrasive particles we are using, I'm going to study here in the impact cutting parameter for speed, feed, depth of cut. In owning the weight bondless wheel, create the ideal cutting parameter owning the compound and to tentative and symmetric distribution condition, the advanced heat dissipation is found method. It's very important how the heat is dissipation, how that the heat is to be the grinding will be it will be spoiled or not. And the principal destination of this examination while doing my problem statement to study the exhaustion of how the precision stone wheels the found that operating some cutting parameters. So in the we consider, right? You see in this picture, have you, I think so, everyone observe special tools, like the one is, you see here, sorry, how it make it special tool, how you can make the grinding tool. You see my picture in the sun, A, B. It's on stem. The stem is it should be making one kind of field that surrounding we can impinge all the diamond abrasive particles. You see in one a bondless wheel with and without shank. First we can make wheel like this. It's a small wheel. It's a small wheel. Where you want to do the machining depends on the area. We can make it that small wheel. That small wheel we are going to, after it should be strong, we can put the stem for the purpose of holding that tool holder purpose. So once that wheel we manufacture, you can make it with the stem accordingly as per the tool jig or whatever tool holder with hole with the chip of avoid the zero velocity. That's very important. It's very, if you see the B1 with hole for chip and avoidance of zero velocity. While doing the operation, you have to be one grinding operation. You can carry for this one. I show you the picture. You see here. If you clearly check this picture. So in this mission, you are going to be constant. You can going to be check here. You see here. Here you are going to fix the material. So I'll come to the point first here. Okay. Now, hello. Can you hear me?
Yes, Professor. We can hear you. Go ahead.
Yeah. All right. So in this grinding operation, once the tool will be special tool will be making this special tool with the shank that you are going to be assembled. First of all, grinding operation with different speeds we are going to check. But different speeds means not its normal speeds. It's thousands of speeds. I will explain to you in this scenario. And temperature analysis, how the temperature will be stable or not. The second one is microstructure, and then data analysis. It should be control, and then discussion and conclusion recommendation. How I am going to part this one by one, we'll see one. Operating parameters, diameter tolerance. You see the diameter of this one, the tolerance also you should know, clearance rate and some. The tolerance and surface condition. You can see the surface condition. Either you're doing new surface, fine surface finish, or you're going to be rework like aeronautical combustion chambers surface condition. So first of all, you have to see the condition surface based which operation is with the hard and medium and low parameters, and then grinding operations based on the environment. In this environment, there are two types of environment. One is dry condition, and the second one is LN2, liquid nitrogen, cryogenic environment. I tested both dry and as well as cryogenic. In the dry condition, the tool life will be decreasing, but in the cryogenic one, the tool life is increased, but the maintenance and the extra additional inputs you need to focus on that. We'll see one by one. The grinding operation and critical depth of cutting in the grinding. So how much the critical depth of cut you can do the one. So if it is more than that, the wheel will be spoiled. The temperature analysis. This temperature analysis you have to check is the 30 meters one and feed and depth of cut. Right? And then in this case, the analysis, how you are going to do the analysis. The chip was produced using emulsion based coolant. Just now I explained there are two types of conditions. One is a cryogenic environment, another one is dry environment. In this cryogenic environment, how you are going to do the one, I will show you. You see here in this picture is with the help of cryogenic environment. You can observe my cursor. The material tool, this is like very, very cold. Once you do the machining, automatically what happens, the liquid nitrogen zone is completely covered the tool. This is my tool. This is the job is completely, because the temperature not will be distributed along the job and immediately get cooling and immediately can get fine finishing. That's very important. That's what I mentioned. The first point is appearing cryogenic liquid nitrogen grinding as the material became a brittle. due to immense decrease in surface temperature that allows easier chip breaking and extend to tool life. Here we are going to concentrate the tool life. In this case, the cryogen should be important, the liquid nitrogen. If you are not concentrate the tool life, then you can go for a dry, but dry condition is a dry condition parameters for rework. You can do it. But while coming to that high cutting parameters like depth of cut is more comparing to and speed, high speed, then definitely you can use this like liquid nitrogen. And coming to the second point for this analysis, while efficiency wise, the tool life in parting, grooving is different scenarios. And cryogenic, the CO2 applied at the rate of about is component coolant. This is well, like threading something, some kind of parting, grooving. This kind of things have a certain length to life. However, surface finish was not improved. The grinding force was not reduced. Yeah, it's true. It's practically I checked already. And surface produce the best surface finish using lubricant during the grinding. I do the grinding experiment. Surface finish will be the lubrications. Yeah. It's dry condition, maybe other operations like turning or milling, but the grinding is neat. While starting with the grinding operation at the speed of 5000 RPM, I'm going to test 2 RPMs. They are spectators. This we have to observe here, clear, pinpoint the speed of how much speed you have to do. That is 5000 RPM. The tool, I just now show the tool will be rotated at 5000 RPM. It touches the tool. What happens? It automatically either tool will be spoiled or workpiece, that surface finish will be on some. But if it is workpiece, we can do a rework again, fine. But the tool will be touched automatically. What happens? The bonding, it's not properly the tool, because the tool is very expensive. This is not normal tool, normal grinding wheel. Please make sure this is not normal grinding operation, not normal market available. This is a special tool manufactured by Malaysia. One of the professor University Malaya, he is going to be concentrated because I'm the member in the team. So I have to clearly observe how making the type of tool. So the tool you are going to be order and you can get the tool. Using the tool, we can do this kind of 5000 RPM and 8000 RPM. At the speed of 5000 RPM, diamond wheel with the stainless steel shaft worked well, machining of titanium. While coming to 8000 RPM, far by shop means there's stainless steel shop and here far by shop work with better rigidity of, because while rotate that wheel, the stem is far by one, it's very high. That is what if you operate 8000 RPM also, it won't be break the stem. But while coming to the stainless steel, it's a limit of RPM. It says 5000, maybe it's 5600 or 6000 can operate. But if it is crossing the 10,000 something, the stem is broken or depends on the wheel. So that's very important here. If you this operation, while before operating the grinding wheel, if you know the parameters and conditions of this one, so easily you can get the fine finishing of grinding parameters. The conditions of this one, just now I explained. The surface, if it is more than how, it is less than 5000 is stainless steel, if it is 8000 is carbide. Surface is produced from low speed grinding 8000 RPM when wheel is mounted carbide shaft. Whereas surface experimental is a speed of jig grinding rotator. 150,000 RPM also uses. A stainless steel shaft is surface parallel and perpendicular also. That is, surface is parallel grinding and perpendicular grinding also. The piece is like this. You can do that parallel and perpendicular. I show you in parallel do that grinding operation, how it could be, and perpendicularly do the one, how it could be. I will show you the both results. Of course, it depends. While sometimes the combustion chamber, take the example is the combustion chamber of aeronautical, the aircrafts. The side walls or need parallel, and bottom and top need that perpendicular. Why? Because the fuel will be flow on this one. This perpendicular, this is parallel. So what happens? The flow of fuel will be circulating parallel. For that purpose only we are doing parallel and perpendicular. Also produce a best flatness and a cryogenic conditions at low and high speed respectively. The highly ductile titanium alloys produces and moderately long chip with the produce. Depends on where of cutting to traffic. Yeah, that's very one conditions on this one. You see, my working operation, I'm using one miller. I'm going to attach that machine with this stem. You see the first beginning, I observed, you see this picture A with the stem, the corporate stem, which you observe my, what is that, cursor, please, the spectators, please look on the cursor. In this cursor, this stem, I'm going to fix with the tool holder here. You see here, I fixed the tool holder with the tool. And what the scenario here going to, these are all cryogenic. Machine under room temperature and workpiece is immersed with the different speeds. Workpiece is different speeds. So here what happened, I'm using the bonding wheel, the grinding wheel arrange. I'm going to apply 5,000 to 8,000 RPM using this machine, and I'm going to do the machining operations here. So while applying the cryogenic, you got inside the cryogenic liquid nitrogen is special one. I just apply the cryogenic. So what happens? You see it makes like a foam. The foam will become like this because immediately capture it immediately take away that heat. It's not dissipating when the heat is developing either parallel or perpendicular machining operation. Heat automatically escapes. So that is the one here I want to explain. While coming to here, the condition 150,000 RPM uses stainless steel shaft, surface parallel and perpendicular also produce best flatness and a cryogenic condition at low and high speed. If you do that, this kind of RPM with cryogenic only can possible. If dry condition, definitely it's a spoil tool or stem, mostly in the tool, but tool is very expensive. That I want to explain in this scenario. This cryogenic condition, the respect to it. You see in this picture, moderately working. Okay, so once it open the cryogenic, and if you see the force and time with the grinding wheel, how it could be perpendicular and parallel. While coming to perpendicular time factor, how it could be the force. So I just up to the 80 newtons or 60 newtons I'm going to, but as per you see the beginning slide, I show you the parameter. You can make the parameter bending strength and like this parameter, you can use these parameters. But I just apply based on this force and time, I can get that finishing. And here the concentrated, the timing, each and every time is increasing minutes, automatically the force also increasing. With the 40, can within 1 minute, and up to the 65 minutes, you can do 60 newtons application of grinding wheel. Automatically you can get the result. So in this part, the bonding wheel machine, how you are going to do the cooling and LN2 operation, you see here in this picture. Yeah. Here we are operating, you are going to set the speed. Here we are going to set the speed here. While you set the speed, you apply this one inside the cryogenic cylinder, the LN2 oil. That LN2 cryogenic liquid nitrogen, it will display like a form. So once you've done this one, it shows the parameter how the speed is either 8,000 RPM or 5,000 RPM. You can test. It's not 5,000 or 5,001, 5,002 or 6,000 something. You can make it drastically 25% increase in speed. Then automatically that much of speed, the machine also vibrates, right? So in this one, you touch the metal automatically. Once the test the tool will be made, the material automatically what happens, it says the form of liquid nitrogen, and immediately what happens, the workpiece getting cool, and the material will be removed layer by layer. So what I'm going to express in this operation, in this research, the bondless diamond will machining titanium alloys with conventional coolant coil. Bonded grinding is another super abrasive next only to diamond. That's what I'm explaining. The diamond will, the abrasive particles all mostly diamond abrasive. It's not normal one abrasive particles. Because the titanium material is very hard, it's a very tough material to do the machining operations. It's not easy to do the machining like MS mild steel or something like that. But this one needs special tools to remove the material, to increase of force and speed. Applications of LN2. In this way, just I mentioned conventional cooling to iron. But applications of LN2, the bondless diamond grinding of titanium alloys results in excellent surface finish, nanometric finish. You can see 0.000, you can get it, one something like that. If you quite, you have to check the depth of the one, it's a micron, it's a millimicron, nanomicron. Nanometric range also, you can get that much of fine finish using this kind of grinding. Yeah, you can. So that's what I'm giving my suggestion to the whoever or do the research on titanium materials using grinding operation. This test is very good. The nanometric range at low speeds and LN2 liquid nitrogen grinding hardness of titanium alloys and operating it is not good to fatigue application, but this needs to be investigation. So of course, sometimes fatigue application is not applicable, but investigation wise you can. Nowadays more in Malaysia, these kind of scenarios more on machining, manufacturing parameters on manufacturing machining parameters on titanium material, because nowadays aerospace and also medical, dental, medical field like bones or something like that. They could use to put the steels or whatever the plates or something like using the titanium corrosion resist to first of all thing. And you should know the how to do the machining with the nanometric finishing. That's very concentrating on this one. You see my overall summary how I want the surface created by the new technique. This is one kind of new technique. How you are going to use the LN2 operation, this liquid nitrogen used to machining with the nanometric finishing, the less time. It's very even a new technique to deliver great measure. The results demonstrated that utilize of universal useful machines can actually yield regarding the mixed bag of lens without utilizing any uncommon machines. Of course, while going to apply this stem, at beginning I show you my tool. This tool, you see this tool? Okay. So while application of this tool, we have to check either the machine is conditionally ensure the 5,000 RPM to 8,000 RPM, then only you can use this kind of. Or else the bonding will, the surface getting up and down. One side is getting chomped or one side is getting one. You can't get fine finishing, fine surface finish on that. So it depends on the grinding surface also, the one. So yeah, that's atmosphere scenario utilization. The bondless diamond will machining titanium alloys with conventional cooling quite well. Just no is a thermal analysis. Yes, I'm going to tell here the thermal analysis means I show you in the picture now. Yeah, you see here this chart. Grinding operation, right? After you do the grinding operation, you can check the 5,000 RPM how it is. You can take the samples. 5,000 RPM one sample, 8,000 RPM one sample, and 15,000 RPM one sample. You can check the operation condition. Then you can simultaneously check the temperature analysis of 3 places. Of course, whoever do the research on this one still got some next future research. This research is stopped up to here only. What the next research we are going to start here? You can see that 5,000 RPM surface finish with the speed of 5,000 RPM, and the speed of 8,000 RPM you can check the surface finish. The speed of 115,000 RPM you can see the one, and you can check the temperature analysis. Of course, definitely the low speed temperature, high speed temperature automatically. So you can check the temperature analysis. The second point, and you see the microstructure. After that temperature analysis, you can go and check the microstructure. The microstructure is different. I'm telling you the scenario. What is the parallel or perpendicular? You can see the microstructure is different. You can get it the objects, and you can take the data. So based on this data and this data, you can check the comparison. The 5,000 how you can get the finishing, and the 8,000 through RPM how you can get the finishing, and the 1,500 or 50,000 RPM how you can get that one. You can both take the analysis, but definitely it shows one parameter is a good fine nanometric. That is, it's not only 5,000, it's not only 8,000, it's not only 5. In between case also you can get it. So you can get some parameters, this much of parameter, this much of depth of cut, this much of feed, you can get fine finishing. That is our discussion. Of course, the limits I'm giving 5,000, 8,000, and 15,000 someone. But you can get nanometric finishing maybe after 8,000 also you can get it. That discussion, and if you do the conclude and the recommendation, you can give it. And if you see my last here, okay, and which is another super abrasive next only to diamond. Next after diamond, results in increasing of force and VU. A study of thermal analysis, critical depth of cut, and dimensions. In this study, what you are going to do, thermal analysis, just now I explained how you can do the different things with the thermal explain, and a critical depth of cut. So you can see the parameters, which parameter you can use, which one you can get it the one. That is the critical depth of cut. This depth of cut you can get fine nanometric finish. That's all. So that's very important. And vertical dimensions is okay. So how you can get it? The finishing, fine finishing. You can check the surface finish methods. So you can get it the one. And this one already I started 2012. I think I started in this research 2012. I can publish many papers with collaborated with some Indian professors also. So yeah, one of Dr. Prahalad Rao from JNU Anantapur. I can share this. I was in Malaysia. I can share this research. So I can just proceed with or is there some Scoopus journals or publications, some kind of thing. And next, John Roger, he is the professor at VIT, Vellore Institute of Technology. So I can share with both, and I can just share my views and everything. And then not only that, Indian professors and one of the foreign professors also I can make, but mostly Dr. K. Prahalad Rao in this area more. So I can just explain my support of research. So I can keep on the publications more on 2015, 2014, 13. I started this research on 2002 until the research is going on. So 2012 to 2015, I can start to concentrated focus on grinding operation, and 15 to 18, I focus on turning operation, and 18 to 20, now my research is going on milling operation. So in this milling operation, I can find out how I can find out the grinding operation using special tool of novel grinding diamond the finishing, and similar aspect in milling operation. What kind of milling operation? There is no specific. It's kind of some combination of tool, CBN, big boron nitrous tool, and PCD polycrystal diamond tool. All right. So polycrystal diamond tool and heat treatment, induction method. I'm going to apply how here using cryogenic liquid nitrogen. Similarly, in the milling, I'm going to use the induction heat treatment. That means what? Here in the grinding operation, using cryogenic, some kind of application. So we do the fine tuning. But in milling operation, it's not a special tool. The tool is similar, polycrystal diamond. But how I can use the milling operation to get the parameters? I'm going to introduce some induction heating method. That means what? The base metal, that material, you can give before you're going to start the machining operation. You're going to give the temperature on this. That means what? You have to get some hotter piece. Slowly you can do the temperature with the help of induction coil. So once induction through the induction coil, the base metal will be getting very with a high temperature. Then that temperature, the tool will be come to the PCD or polycrystal or CBN tool, do the machining, the milling operation. Automatically what happened? It became a softened material. So easily what happened? Removed. But the problem here is coolant, because this job already in temperature, with some temperature. So the problem I'm facing here, by do the milling operation, the material will be built together with the thick edge of it. So now I'm going to introduce some kind of environment, cooling environment or tool only, not the workpiece. That I'm going to do the research. So this is a broad way, very area, many applications is available in this Titan, either using turning operation, drilling operation, milling operation. But I'm not focusing my drilling operation. Up to now, grinding is over, turning is over. Now milling. In future, I'm going to concentrate the drilling operation. Of course, if milling is success, automatically drilling operation is possible. Drilling is only for holes. But nowadays, we are not looking for the inside the hole of how is the parameter. Only we are going to concentrate the full face of the material along with the traverse, is the perpendicular or parallel the surface finish. That's only we are going to look in the fine parameters. That's what I'm going to focus on. Yeah. So, and also Dr. Air Babu is my professor when I was in, and also want to say something. I'm very happy to share with this organization. Why? Because I'm a student of this organization is a 20 years back, the second batch of the student of research. So I'm very happy to share this event with where I'm studying my and the knowledge with the Professor Air Babu. He was my lecturer at time. He's a professor now. So I'm very happy to share this information, my research. Past Malaysia, 10 years I'm working, and 2 years in Oman working, now present in Ethiopia. And next year I'm going to be Dublin, Ireland for do as a research on this one. So this is my next future target, do the drilling operation, this whole scenarios in the month. I did for this kind of research. I'm take away along with the whole country to do how to do this research. So this is my presentation. This is my what is the views on the titanium alloys. Okay, so that's all my presentation today. You have any queries or questions also, you may please now.
Yes, Professor, we have a question from the participants.
Yeah, please.
As you mentioned that you had carried out your thermal analysis.
Yes.
So what is the device used to measure the temperatures? And followed by question. So what is the maximum temperature that you had been observed?
All right. So they got some thermocouples. Temperature couples is the one sensors is available. That sensors is it's a very high temperature. So you can measure it's more than is a 5 to 7, 5 to 8,000 degrees centigrade, something like that. So you can use that sensors, the thermocouples, you can use it. But sensors is very expensive. But while coming to thermocouples is available. So I will give that information where you get that kind of temperature analysis measurement instruments. You can use that instruments. You are going to be fixed with that nearby the material where the touch that area of the tool, so you can get the temperature results.
Okay, thank you, Professor. One more question. What is the percentage of efficiency has been improved by using the non-cryogenic and cryogenic things?
Yeah, that's very good question. Yeah, in the dry, its efficiency, of course, is a coolant. Dry condition, wet condition. Of course, wet condition you can get more efficiency compared to dry condition. But the dry condition, if you see that that efficiency wise, it's not very down, very high. It's moderately can get a good performance, the efficiency. But while do that, it depends on the what is that scholar or researcher. It's going to choose that application is a dry or wet. But efficiency wise is of course dry conditions, wet conditions. You can get more strengthened and more results. It depends on the parameters. In these parameters, this is good, and that parameters that's good. So dry condition, but the dry condition, the maintenance and the tool life will be down. That's only the scenario. Remaining all not much more.
Thank you, sir. I think I request the participant to unmute, and you have any question you can ask directly, Dr. Anand Yaru. Or you can raise your hand so we can unmute you and you can ask the question. So, Professor, can you? Is it possible to collaborate with you for future work, if anything?
Yeah, sure. Yeah, guys, I will give my, I'll just give it to my email ID and my contact, foreign contact with Dr. Harinath. You just get it from Dr. Harinath. Wherever I go, I keep in touch with me. Because, see, I mentioned all in my supporting research, that time I couldn't find whoever interested in this area. But I checked as per university-wide, Dr. K. Prahalad Rao is working on this materials and machining kind of thing. Then I can approach from Malaysia. So he said, okay, right, I will give my input, some parameters, something like that. I can just share with these things. So he is also professor, so I can, and also Nagamaleshwar Rao and A.R. Babu, I can join with. If you please want to join with me, I will give some work. We can do that one, whatever I will give the suppliers details on everything where you can get the one. You can do the one. I can make you the team, doesn't matter in future, because next year I'm focusing on Dublin, Ireland. So they're almost going on the work. So due to COVID, it's delayed. So maybe next year I will be stepping the island, so I can start this research. So I will just I will give my contact details and Dr. Harinath. Please, you may collect from Dr. Harinath, and he will make the team. He will do along with that. No problem, doctor.
Thank you, Professor. It's an informative session from you. So I now request our HOD, Dr. Vijay Bhaskar Reddy sir, to address the things. HOD sir.
Yeah, Dr. Vijay Bhaskar Reddy. Thank you for giving this opportunity, Dr. HOD Garu. So I am the second batch for this engineering college, Doctor. I'm a student of your college as a second batch. So now it's growing means because of your blessings, like your research and your supporting and your kind of. Hello, hello, Doctor. Can you hear me?
I can hear you, but I think our HODs are maybe busy.
Okay, right, no problem.
So there is one more person raising their hand.
Now you can do.
Okay.
I proceed.
So HOD sir.
Yeah.
Yeah, yes sir, yes sir. Dr. Anand is here.
Yeah. Good morning to you all.
Good morning,
So
sir.
it's my pleasure on behalf of Sri Venkateshwara College of Engineering. I am very thankful to Dr.
Anand.
Anand Kumar Garu, because whatever you have told, that is you are of our alumni student. And another thing which I wanted to tell you is Dr. Nagamaleshwara Rao Garu is my senior in Polarity Engineering College.
Okay, great, Doctor. Okay.
And this Prahalad Rao sir also is,
Okay.
I know Prahalad Rao sir also.
Okay.
So
Okay.
we are feeling very happy for you to be with us in this day.
Okay.
And I'm very thankful to all the participants who have participated for this session. And I think Dr. Nagamaleshwara sir is also present in this session.
Yeah, he's very good, Doctor. He's also giving some inputs when I was in Malaysia. So I couldn't find some of the professors, but Dr. Air Babu is a researcher of the thermal and materials. But Dr. Prahalad Rao and Nagamaleshwara both are in material and machining. So that is what I am just whatever do the parameters because University Malaya they're asking me, do you know any professors in India so you can just get the information of parameter with some inputs from them. We can do the one. So in this case, 5,000 to 8,000 scenario, I'm just getting the inputs from Prahalad Rao. He said, okay, go ahead, Dr. Anand. You can do the test one. If it is the tool is broken, doesn't matter. We'll see the finding, the analysis, all kind of things. Then I started. Then I can get a good results of a parallel and perpendicular. Then I can share with that Prahalad Rao, Dr. Prahalad Rao. He was there. Yeah, of course, I'm just giving that the trial and error information inputs, Dr. Anand, but you've done a good job. So then I published a lot of papers under him, Doctor. So that's what I was very happy. Now I got to get it with the help of to Dr. Harinath. I got to getting a good channel and Dr. Vijay Bhaskar Reddy also. We together we can do because next year I am planning to go Ireland, Dublin. So I had to make it this kind of research and drilling operation. So already finished in the turning and milling and the grinding. So now I'm started with the drilling operation. So we'll see how it is one. We can make it a research team and one group and we can do it, Doctor.
Thank you very much, sir. We are very happy.
Yeah.
Thank you, sir. Thank you very much.
Thank you, Anand, to being here with us.
Yeah,
and it's informative session. So definitely we'll come back with you for a future collaboration. So we have an expertise in both thermal and manufacturing. So I was in welding. Professor Vijay Bhaskar in thermal side. And we have one more.
Welding in Taguchi method is there. So I can just share with one with using the Taguchi method, the welding techniques is there. That's also one of the ones. We can share with that one. Doesn't matter, Doctor. Good sharing.
Thank you, Professor. Thank you for informative session.
And once over, I want to say special thanks to Dr. Air Babu. He is only that channel, the bridge to from me to Dr. Vijay Bhaskar Reddy and yourself. So thank you, Dr. Air Babu. Right? Thank you so much, everyone. So,
thank you,
Doctor, can I leave the one? Can I leave?
Yeah, you can.
All right,
leave.
Doctor. Thank you so much.
Thank you very much. I'll get back to you later.
Yeah.
So dear participants, today we end the session. So you will receive the feedback on the 15 minutes via WhatsApp groups. Thank you for us. Tomorrow we have a session, 2 sessions. So one from the Dr. Barnidharan from Vellore Institute of Technology. So another professor from NIT. So another from Tripura. So we will be in, there will be 2 sessions. One is on 11 to 12:30, and the second one is 2 to 3:30. Thank you all.